Okay, good morning and welcome. How many of you remember the dot-com bubble and the subsequent dot-com boom? It was a time when companies were pioneering the internet, and they were facing the challenge for the first time of providing a reliable infrastructure at the same time as innovating fast. It was a time of magnificent names. I was the president of a company called Ogoli.com, Ogoli. And at Ogoli, we really allowed people to develop very simple websites. The Ogoli platform was an IIS application on top of Microsoft SQL Server. And the SQL Server contained the website data and the website configuration. And for Ogoli to succeed, I knew we had to do two things. We had to keep the customer sites up and running, and we had to add new features to those sites at a fast pace to kind of attract new customers. And I had a really experienced DBA, he knew SQL Server backwards, and I said to him, please focus on keeping the database up and running to keep our existing customers happy. And I had a brilliant young dev lead, and I said to that dev lead, really roll out functionality fast, let's get new features, let's outpace the competition. So with this brilliant strategy, we set out with high energy and high hopes and enthusiasm, and it didn't quite work. And the problem was that I couldn't get my DBA and my developer to work together. I want to fast forward 13 years and introduce you to two current-day superstars, Steve Jones, a DBA, and David Simner, a developer, and they're working on Redgate's Simple Talk website.
Well, good morning, everybody. Thanks for coming out here on a beautiful day in Charlotte. Lovely weather outside. Is everybody happy? Yeah. I think these guys brought it with them, so it's their fault. It's a great day to be a DBA. I know that because my phone didn't ring last night, and all my systems are running great. If I look here, I have a monitoring system set up, and I can see that I have no problems going on, everything's smooth. But I knew that before I woke up, before I came here today, because if I had had a problem, I would have been alerted. Somebody would have called me. And I think that's the hallmark of an exceptional DBA. He or she has monitoring set up so that if there are problems, we get alerted right away. And maybe if we're really exceptional, we have alerts come to us before there's a problem, and we can proactively fix them. And we can see here there's nothing going on. You know, if I click through it all and look at my host or I look at my SQL Server instance, I don't see any issues in here. And these days, there's no reason for a DBA to be going through here, checking logs, or trying to see if jobs ran, or if there's any errors or anything else, because those are the tedious, easy, mundane things that people don't really want to pay you to spend your time on. They want to pay you to add value to their company. And that's what I try to do at my desk. You know, I want to add value to my company. That might be proactively tuning queries. It might be finding new ways to test and prepare for patches or upgrades or enhancements. It might even be practicing my DR skills with periodic refreshes or restores so that if I have an issue, I have the confidence and the skills to solve the problem right away without fumbling around. So everything's running great, but I see I've got my lead developer, David, here. So what's on the agenda today?
Hi, everyone. So we'd like to deploy an update to the Simple Talk production site.
So is this a small update that I have to worry about or a big update that I really have to worry about?
So it's pretty small. So let me show you what we're going to do. So this is what's currently running on production right now. So this is the Simple Talk homepage. It's got a list of articles here. And for each article, we've got the author, the date it was published, and how many comments it's got. And we've had a feature request from our users that they'd like to know kind of how big an article is without having to click through to look at it. So if they've got a 5-minute kind of coffee break, they want to know if the article is short enough to read in 5 minutes. So this is what we're going to deploy. As you can see, we've added just an extra bit of information here that wasn't there before, which just says kind of how big the article is, whether it's a minute to read or 20 minutes to read. So just one small bit of text.
But we're going to have to touch the database schema to make this change, right?
Yeah, so this update cuts across both the website and the database. The website needs to get changed to render this extra bit of information, and yet we're going to change the database schema as well.
So anytime that we're going to make a change to either application or a schema, we run the risk of introducing bugs and potential problems for our users.
So we've unit tested this. It works perfectly fine on my machine. It's just one small little bit of text next to each article. I mean, what can possibly go wrong? It's going to be fine, I promise.
So, David, I know you've got a great team of coders, and you do a fantastic job writing applications, and you probably deserve a raise, actually.
John, you hear that?
But anytime we make a change, we could introduce a bug. And bugs, by nature, are unexpected. We don't know when they're going to occur. If we knew, we'd just fix those in development. So before we make any kind of change, any upgrade, any enhancement, any patch, any deployment of anything at all, we want to do a backup. It's just a prudent thing for a DBA to do because we're conservative and risk-averse by nature. These business guys seem to want all their data, and so if anything goes wrong, I have to be able to recover all that data. But don't worry, not going to take very long at all. I've got a job already set up that I can run very quickly with just a couple clicks to run me a backup. And I've got tooling already set up in advance, as an exceptional DBA that allows me to quickly and easily do these backups and see that things are happening. Now, I've tested these ad hoc scripts. They're ready to go. Before I make any change to my system, in my instance, my database, any kind of enhancement, I run an ad hoc backup. I do that to make sure that I can recover. And I also have it scripted so that if there's an issue tonight or tomorrow or some other time, I don't interrupt my backup chain. I don't interrupt the recovery process that I have in place. I have the copy-only flag preset on here, so it's not going to be a problem. I don't have to find this backup if I have an issue. The backup's done, of course, but I always want to make sure that I actually have a physical file. The reason is that I want to be sure the backup ran. My script should work because I've tested them, and the tools should let me know if there's a problem. But if there is any issue, I want to be sure that I can find this file, that I'm not fumbling around trying to figure out where it is. So I've got the file here, so I'll let David go ahead and do his deployment now.
So you see what's happening here is these two guys have got different goals. Steve's conservative. He wants to protect the data infrastructure. He doesn't like change. And David's championing at the bit to roll out change and deliver functionality fast. And back in the old golly day, I started to realize that this, in fact, was the problem with my developer and my DBA. It really felt at that time like the goals were totally mutually incompatible. Let's see what happens now.
Cool. So now that Steve has signed off, let's go ahead and do the deployment. So to do the deployment, we're going to use a Redgate tool called Deployment Manager. So let's go ahead and deploy the new version. So we just need to pick the environment that we want to deploy to, so in this case, production, and then click Deploy Release. So what Deployment Manager is doing here is it's deploying the release. So before the demo today, I created packages for the database and the website that I wanted to deploy. And Deployment Manager is a package-based deployment system. So it copies the packages over to the target machines and then does the deployment from the packages. So the database package contains the schema and the static data, so like a list of countries in some of the tables, for example, for the database that we want to deploy. And we use the Redgate database tech to look at what's in the package, to look at the live website running on SQL Server and generate the necessary alter script. And then to do the database deployment, we just run that alter script. The website package has got the HTML, the CSS, the JavaScript files that run our website, as well as the .NET binaries for the dynamic content. To do the website deployment, we just extract the package onto the file system and then configure IIS to serve the site from the new location. So it's with just 2 clicks, we've deployed a new version of our website and a new version of our database together to production, and it's done. So let's go ahead and take a look at the production site. So if we just refresh that. It's taking a bit of time to load. That's probably just the app pool starting up. I'm sure everything's going to be fine. It was only a small change anyway. So we're done.
So David deployed that application with 2 clicks. And we know that, in fact, behind the scenes, there was a bunch of activity. We had to compare the schemas. We had to compare the reference data. We generated change scripts to make the changes. We put those changes into source control. We staged them, and we tested them. So a bunch of activity that happened behind the scenes there. But the striking difference between now and back in the old days is that was entirely automated. And it's only possible to automate because of the tooling that now exists to do that heavy lifting, to compare the schema and put things in source control and that kind of thing. But the benefit of that automation is that we start eliminating human error and we start getting a repeatable process.
So we can see that things are ready to go. They're working, kind of, or actually they're not. I've actually just got an alert on my phone. And if I flip over here to SQL Monitor, I'll actually see that, in fact, I do have an alert that's popped up. I'll let you. And if we drill into that, we can see that, in fact, we've got a problem with a long-running query, which is bad. Now, I don't know if this was caused by the deployment, but I do know that I've got a problem on production. As DBA, I have to look into it and figure out what's going on. I do see it's on a SimpleTalk production database, and the query took 8 seconds to run, which is a long time to run a query on a web page. That's unacceptable for our users. If it takes 8 seconds to run the query, it takes over 8 seconds to render that page, which means our users are waiting. The other problem is 8 seconds for one query on my database server means that could stack up over time, could cascade into problems with other processes and other applications, and put a strain on my database server.
So we're in trouble. But within 1 minute, we've got a pretty good idea of where that problem might be. Over the past 10 years, there's been a bunch of changes to the way that people develop software. People are starting to develop in an agile manner, so they're planning more frequently and developing small chunks of software. And one of the logical progressions of that is people are starting to deploy very small chunks of software. So you notice that David, in fact, released or deployed one feature. And part of the reason they're doing that is, in fact, to try and build resilient solutions. Now, the best way to think about resilience is to think about a BMW and a Jeep. A BMW is pretty reliable, so it hardly ever fails. But when it does fail, it can get quite complicated. You've got to take it to the shop. If you've ever looked under the hood of a BMW, it's not easy to fix. So it takes a long time to restore or to get back and fixed. A Jeep, on the other hand, and I'm talking about the kind of Jeep that you drive through Africa, fails pretty regularly. But you can fix it. You can reassemble the entire engine in 4 minutes. So you can restore service. And the mean time to restore service is therefore very, very short. Let's see how resilient the SimpleTalk website is.
Cool. So let's fix the performance degradation that we've now got on the production site. And to fix it, we're going to deploy the previous thing that was running on production. So again, we're going to use Deployment Manager and click Deploy this release, pick Production, click Deploy. So what Deployment Manager is doing is it's redeploying the thing that used to be on production before we deployed the performance degradation change. And this is one of the great things about Deployment Manager. We don't need to, so without Deployment Manager, we might need to go hunting around network shares to find the version of the database we used to have on production and the version of the website we used to have on production, make sure we've got a version of the database that works with that corresponding version of the website, and put it back where we were. Whereas with Deployment Manager, because it keeps all of the releases for us, to get back to where we were, we just need to find the release, click Deploy, and in the same way that it can install upgrades, it can also install downgrades as well. So in just 17 seconds, which is how long it took to do that deployment, production is now back to where it was before we deployed the breaking change at the start of the keynote. So if I go ahead and refresh the production site, you can still see it takes a little bit of time to load. That is the app pool starting up. But subsequently, if we refresh the production site, you can see from the icon in the top that it loads in no time at all. So we're now back to where we were without the performance degradation change, and we can go into SQL Monitor and clear that alert. And SQL Monitor says that everything else is fine. So we're now back to where we were. Production's working fine.
So that was pretty good. You know, really, they kind of got back up and running pretty fast. But here's where the fun often starts. We had a bug in production. So what you often find is the finger pointing starts happening now on the accusations, and the DBAs are blaming the code, and the developers are blaming the database. And it gets quite fun, doesn't it? It actually gets worse as well, because quite often you find that developers are reporting into one side of the organization, DBAs are reporting into another side, they're using different tools, they're using different systems. So it's really, really hard to get the two of them to work together to try and solve the problem. I wonder if Steve and David can work that out.
So SQL Monitor already gave us an alert, told us that we had a problem with the query, so now we have to dig in and see what that was.
Cool. So let's take a look. Oh, no, we do that a bit first, don't we? Cool. So whereas SQL Monitor is a great tool for Steve and for DBAs to give you alerts and their long-term analysis trends, the tool that I love is Ant's Performance Profiler. So Ant's Performance Profiler, or APP for short, is designed for developers to let you focus on which bit of your application is running slowly. So there's lots of different reasons an application might be running slowly. Maybe we've got some really inefficient C# code. Maybe we're doing lots and lots of file access to slow disks. Maybe we're calling into a third-party web service to generate our page. Maybe some kind of payment processing gateway, and maybe that third-party web service is slow. Or maybe we're just running SQL, and the SQL's slow. So no matter what the cause of the performance problem, whether it's inefficient C# code, inefficient SQL, inefficient file access, or a third-party web service that's slowing us down, Ant's Performance Profiler will show that to us really easily. So you can see that to render the web page, we run two different SQL queries against the database server. So this one is getting the list of RSS feeds, and we use that to show this list in the top right-hand side in the custom RSS feeds. And that SQL query took just 12 milliseconds to execute. So that's really good. 12 milliseconds, perfect. Whereas this SQL query here, which is selecting from the articles view, took 8.7 seconds to run. So this is the query that was causing the performance degradation, and this is the query that we should then dive into a bit further to see what's going on.
And as a DBA, I love the fact that we get independent confirmation here. SQL Monitor, my monitoring system told me that I have a problem with the database server and with queries. But now from this side, I get confirmation that that is in fact the problem, that we can see from the developer side that the SQL is in fact running slow. Now it's up to the DBA and the developer to actually work together to find out what the problem is and use our knowledge and our experience and our talent and our tools to solve the problem. The monitoring and the development tools point us in the right direction, but now it's up to us to fix the actual issue.
Cool. So let's take a look in SQL Server Management Studio what that view is doing. So this is the view. As you can see, it's selecting from a table, the articles table. We're doing a few joins at the bottom just on some foreign keys, just to get a bit more information to render the page. And then this is the feature that we deployed, which caused the performance degradation, which is calculating an estimated reading time of the article. So let's just go and have a look at this function and see what it's doing.
Don't write functions like this. Grant will be mad at you. And we all know he's scary.
So this is the function. Before we go into the depth of the function, I want to talk about the context in which it runs. So every single time a visitor comes to our web page, we select from the view. So every visitor causes a select from the view, and the view will run this function for every single article which is being returned for the home page. So this function is being run an awful lot, and the problem is it just does too much work. So if you look at what it does, it goes through every single character of the article and sees whether it's a space. And if it is, it increments a counter. It's trying to get a count of the number of words at this point. And then at the bottom, it divides the number of words by 250, because according to Wikipedia, humans can read about 250 words a minute. So this is how it's working out the estimated reading time. And the problem is if we've got lots of articles, or if they're quite long, particularly the articles that take 20 minutes to read, looking at every single character and seeing whether it's a space is just doing too much work. This is probably why we didn't catch it in testing. Maybe in testing, for our unit testing, we probably had like 3 articles of about a paragraph each. So when we test it with that little data, you're not going to find this kind of bug. And this is kind of, production is different to how we tested it. I mean, we should probably have caught this in code review. I mean, or the person shouldn't have written it like this in the first place, but that certainly wasn't me.
But this is fantastic. We've got Steve and we've got David working together. They've still got different goals, but they're actually working together. And the reason they can work together is that Steve's got a watertight data infrastructure. He's monitoring his servers. And David's treating his database like he treats his code. So he's putting it in source control, and he's automating those changes. And in fact, there's an organizational structure and organizational processes that facilitate that interaction. So they can, in fact, work together and solve problems. Let's see if they can fix it.
Cool. So we're going to go ahead and just rewrite that function to be this instead. So you can tell it's better because it's just one line as opposed to quite long. Because we're only after an estimate of the reading time, we can just assume that words on average are about 5 or 6 characters long. So rather than going up and counting a precise number of words, we can just estimate the number of words by assuming they're about 5 or 6 characters long. So we just divide the total length of the article by 1800, and that gets us the estimated reading time. Cool. You happy with that?
Looks good. Let's go ahead and deploy it.
Cool. So what we're going to do now is go over to Deployment Manager and deploy the fixed version. So to do that, we just click Deploy this release, pick Production, and go ahead and click Deploy. So just like the previous 2 deployments that you've seen with Deployment Manager, this one is deploying the website change to put the feature back in, and it's deploying the database change to add our corrected function.
So you can see, it's like 15 minutes. We've actually deployed a change to a website, both code changes and database changes. Our monitoring system detected there was an issue with this change actually being deployed. We found that out. We stopped. We rolled back the change. We used our automated process, the same one that deployed the change. We used to very quickly roll back the change and get to our previous version. Then once we had a stable site, the DBA and developer can work together to solve the problem. We can use our experience and our other tools to dig in and actually find out what exactly is wrong, make a fix, create it, test it, debug it, then deploy it again with our automated process. And 20 seconds, we've done it again. Is it working?
Cool.
Everybody cross your fingers.
So this is production, which I've just refreshed. You can see our features come back. And crucially, if I press the F5 key now, you can see from the icon in the top that the page loads in no time at all. And if we go over to SQL Monitor, it's fine. We're done.
It's looking good. No alerts. I'm happy. My phone's not ringing. David's happy because he can mark this feature as complete, and he can move on to the next bit of code or the next project he needs to do. And I can go on with my day, trying to find ways to make sure my systems run better and add value to my employer. It's a good day.
Golly, I never did get the DBA and the developer to work together. But things have changed. The tools have moved on. Our process know-how has improved. So there's, in fact, no reason why every company can't both protect their data and roll out change. That's the end of our demo. Have a great day at SQL in the City. Learn a lot, talk to lots of people, but most importantly, have fun. Thank you.
Thank you.